Dear students, welcome back to SUMANTH tutorial. In this session, we are going to deal with the content called as critical angle and total internal reflection. The most important topic for grade 10 ICSE as well as for the CBSE students. So let us learn the complete concept about your total internal reflection. Okay, now so let's start with the content. See here, if you want to learn the concept about the total internal reflection, one thing that you should note it down. Till now, whatever the refraction process that we are going to deal with, we used to say like that: the ray of light is moving from air to water, or air to glass, or air to oil. Like that we should say, isn't it? Now see here. Now we are going to deal the same thing in a reverse. Means it's very clear. The ray of light is moving from water to air or glass to air. That is a concept. Means it's very clear, a ray of light is moving from denser medium to a rarer medium. Once again I am telling, if we want to deal with the critical angle and total interreflection, fix your mind that the ray of light is moving from denser medium to a rarer medium. Okay, now see here. See, imagine this is a separating medium. So imagine this is the glass slab. This is the glass slab, and let me draw a normal which forms 90 degree with the refracting surface. As I said, the incident ray, it is from the denser medium. So this is the denser medium, this is the rarer medium, and we know very clearly this is the angle of incidence. Howdala? Now tell me, if a ray of light is moving from denser medium to a rarer medium, the ray of light bends away from the normal. Very good. See here, this will be like this. This is angle of refraction. So make sure the ray of light is moving from denser medium to a rarer medium. This is the angle of incidence, this is the angle of refraction. Here in this condition, R greater than I. So angle of refraction is greater than angle of incidence as the ray of light is bending away from the normal. Howdala? So it's very clear. Here the ray of light is moving from denser medium to a rarer medium. Or remember, it's very clear basic concept. ಯಾವಾಗ ray of light denser to rarer move ಆಗುತ್ತೋ, the ray of light bends away from the normal. Here angle of refraction is greater than angle of incidence. First is clear. Now let me continue with the diagram. The same glass slab. Now what I am going to do, this is the normal line. Now I will increase the angle of incidence. ಏನು ಮಾಡ್ತಾ ಇದ್ದೀನಿ? Angle of incidence ನ ಜಾಸ್ತಿ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. So I am increasing the angle of incidence. Very clearly the angle of refraction will also increase. ಹೌದಲ್ಲ? As the ray of light is moving from rarer medium to a denser medium, if I increase the angle of incidence, angle of refraction will also increase. Means it's very clear, if I extend this line like this, then obviously the refraction ray will also bend away from it. Okay, na? Sure. Now see here, if I further increase the angle of incidence like this, I am continuously increasing the angle of incidence. Now at one particular angle of incidence, the angle of refraction forms 90 degree. This is important. Now see here, this is the first case, second case, and the third case. For my reference we are writing, this is the first case, the second case, and the third case. Just observe the first case, angle of incidence and angle of refraction, R is greater than I. Here also very clearly R is greater than I only. But what is the difference you are observing? As I increase the angle of incidence, angle of refraction is also increasing. ನಾನು ಇನ್ಸಿಡೆನ್ಸನ್ನು ಜಾಸ್ತಿ ಮಾಡಿದಷ್ಟು ಆಂಗಲ್ ಆಫ್ ರಿಫ್ರಾಕ್ಷನ್ ಕೂಡ ಜಾಸ್ತಿ ಆಗ್ತಾ ಇದೆ. ಮತ್ತೆ ಇನ್ಕ್ರೀಸ್ ಮಾಡಿದಾಗ in this case, the most important case now, see here, ಯಾವುದೋ ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ಆಂಗಲ್ ಆಫ್ ಇನ್ಸಿಡೆನ್ಸ್ ಅಲ್ಲಿ ಆಂಗಲ್ ಆಫ್ ರಿಫ್ರಾಕ್ಷನ್ 90 ಡಿಗ್ರಿ ಆಗೋಗ್ಬಿಡ್ತು. ಆ ಪರ್ಟಿಕ್ಯುಲರ್ ಆಂಗಲ್ ಆಫ್ ಇನ್ಸಿಡೆನ್ಸ್ ನಾವು ಕ್ರಿಟಿಕಲ್ ಆಂಗಲ್ ಅಂತ ಕರಿತೀವಿ. ಅರ್ಥ ಆಯ್ತಾ? ಸೊ ಹಾಗಾದ್ರೆ ಏನು ಕ್ರಿಟಿಕಲ್ ಆಂಗಲ್? ಕ್ರಿಟಿಕಲ್ ಆಂಗಲ್ ಈಸ್ ದ ಆಂಗಲ್ ಆಫ್ incidence. Critical angle is the angle of incidence in a denser medium. This is important one. So angle of incidence in a denser medium in such a way that angle of refraction forms 90 degree. This is most important. Clear? So here in this condition, I is equal to C and R is equal to 90 degree. Keep these two in your mind. So what is critical angle? Critical angle is the angle of incidence in a denser medium such that the angle of refraction is 90 degree. ಯಾವುದೋ ಒಂದು particular angle of incidence ಅಲ್ಲಿ angle of refraction 90 degree ಆಗ್ಬಿಟ್ರೆ, see here this is retracing the path. Means this is the refracting surface. So it is along with the line and it forms 90 degree, and this is the normal line. So it's very clear. This particular angle of incidence, we call it as critical angle. Definition is okay? Very good. Now, in a last case, in a fourth case, in the normal, further I will increase the angle of incidence. Then the ray of light bounces back to the same medium. Are you getting what I am telling? See, this is the case number 3 and this is case number 4. Observe case number 3 and case number 4, the most important one. In a case number 3, this is the case number 3 where I is equal to C. We used to call it as critical angle, where R is equal to 90 degree. Howda? But further I am increasing. Here in this case, the value of I is greater than C. ಕ್ರಿಟಿಕಲ್ ಆಂಗಲ್ಗಿಂತ ನಾನು ಜಾಸ್ತಿ ಮಾಡಿದೆ. ಅವಾಗ ಏನಾಯಿತು, ಆ್ಯಕ್ಚುಲಿ ಹೊರಗಡೆ ಹೋಗ್ಬೇಕಿತ್ತು ರೇ ಆಫ್ ಲೈಟ್, ಇಟ್ ವಿಲ್ ನಾಟ್ ಗೋ, ಇಟ್ ಬೌನ್ಸ್ ಬ್ಯಾಕ್ ಟು ದ ಸೇಮ್ ಮೀಡಿಯಮ್. This process is called as total internal reflection. The most important one. That process is called total internal reflection. Then what is total internal reflection? Total internal reflection is a process in which the ray of light bounces back to the same medium as it is moving from denser medium to a rarer medium. Please observe case number 3 and case number 4, the most important one. In case number 3, I is equal to C. We call it as critical angle when R is 90 degree. Howda? If I further increase I na C ginta ಜಾಸ್ತಿ ಮಾಡಿದಷ್ಟೇ it bounces back to the same medium. That process is called as total internal reflection. ಹಾಗಾದ್ರೆ which are the most two important things for the occurrence of total internal reflection? Total internal reflection ಆಗಬೇಕಂದ್ರೆ which are the two very important conditions? The first condition is the ray of light must travel from denser medium to rarer medium. Note this one, very important. So total internal reflection ಆಗಬೇಕಂದ್ರೆ first condition, the ray of light must travel from denser medium to a rarer medium. Ray of light must travel from denser medium to a rarer medium. And the second most important thing is the angle of incidence must be greater than critical angle. These two are the most important conditions for the occurrence of total internal reflection. Clear? Okay, please make a note on these things. Done? Now, I am gonna say the factors on which this critical angle depends. See here, whenever you are dealing with a light chapter, in a refraction, especially with the grade 10 ICSE, the factors affecting are most important here. Factors affecting the critical angle. See, critical angle is a physical quantity on which factor this critical angle depends. Means there are two factors. First is the wavelength. If wavelength is increasing, means it is moving from violet to red. That's what I said. Whenever I am telling that the concept of wavelength, you must fix your mind. I am talking about the visible spectrum. That is from violet to red. See here, if the wavelength is increasing, then obviously the critical angle increases. It is directly proportional. So violet ಇಂದ ರೆಡ್ ಕಡೆಗೆ ಹೋಗ್ತಾ ಇದೆ, critical angle ಏನಾಯ್ತು, ಜಾಸ್ತಿ ಆಗ್ತಾ ಇದೆ. Meanwhile, temperature. If temperature increases, critical angle will also increase. Means this critical angle is directly proportional to both wavelength as well as temperature. Don't forget, it depends on both the factors, wavelength as well as temperature. If temperature increases, critical angle increases, as well as if the wavelength increases, critical angle increases. Sure. This is important one. The factors on which the critical angle increases. In an examination, you may expect the question like this. The temperature of a glass is increases by 10 degree. How a critical angle affects? Clear? If the temperature increases, obviously critical angle will also increase. Sure? Did you note this one? Yeah. Can I erase? Yeah. So let me erase this one. Now see here. Next, how refractive index is related to a critical angle. See here, we know very clearly from second law of refraction, mu is equal to sin I by sin R. Right? It is called as Snell's law. Here, one thing you should remember, as it is moving from air to, for example, here I have taken as glass. That may be water, that may be glass, whatever. See here the refractive index of glass with respect to air is sin I by sin R. This is the general one. Now tell me, for the occurrence of total internal reflection, the ray of light must travel from denser medium to a rarer medium. Now see here, we are going to reverse it. Now the ray of light is moving from glass to air. Means the refractive index of glass with respect to, refractive index of air with respect to glass, right? Then this changes to sin R by sin I. We know very clearly this is principle of reversibility. Then for critical angle, I is equal to C as well as R is equal to 90 degree. Howda? Critical angle ಆಗ್ತಾ ಇದೆ ಅಂತಂದ್ರೆ ಏನು? Angle of incidence is equal to the critical angle and angle of refraction is 90 degree. Now substitute the same thing here. This becomes sin 90 divided by sin C. And we know very clearly sin 90 degree is 1. Hodala, sin 90 is 1. Therefore, this mu, if the ray of light is going from glass to air, this is 1 by sin C. The most important relationship that you must know. So mu is equal to 1 divided by sin C. This mu representing, it is representing the refractive index, whereas C is representing the critical angle. In general, we used to write like this: mu is equal to 1 by sin C. Sure. So I just written how the value of mu is inversely proportional to the critical angle. Okay, please copy this one. I think you people had copied it. Then the question arises, sir, where we are gonna use this total internal reflection? There are many fields, especially with the optical field, we are gonna use this total internal reflection. So one of the best method I'm gonna say, or best uses that I'm gonna say, is for the communication purpose. Communication purpose, we are going to use this total internal reflection, so that whenever we are going to send the information through a long distance, the energy will not going to lose, and what is the input and the output remains the same. There is no loss of energy, so we can transfer information through a very long distance through OFC. I think you people have heard this. OFC stands for optical fiber communication. So in optical fiber communication, we are going to use the principle called as total internal reflection. Through this, we can transfer information through a long distance. Okay, now not only this is one of the example I said, but in a few areas we are going to use total internal reflection, like optical instrument, like periscope, as well as binoculars. They're all we are going to use total internal reflection. Clear? Okay. Yes, students. Now I'm going to explain how this total internal reflection is used in a prism. ಒಂದು ಪ್ರಿಸಮ್ ಅಲ್ಲಿ ಟೋಟಲ್ ಇಂಟರ್ನಲ್ ರಿಫ್ಲೆಕ್ಷನ್ ಹೇಗೆ ಯೂಸ್ ಆಗುತ್ತೆ, ಸೊ ವಾಟ್ ಆರ್ ದ ಪ್ರೊಸೀಜರ್ ಅಂಡ್ ವಾಟ್ ಇಸ್ ದ ಬೇಸಿಕ್ ಥಿಂಗ್ಸ್ ದಟ್ ಯು ಶುಡ್ ಡೂ ವಿತ್ ದ ಹೆಲ್ಪ್ ಆಫ್ a ray diagram that I am going to teach. See here, the content what I am going to explain here, it is most important for your grade 10 ICSE. You may expect one question minimum for the 3 marks to draw the ray diagram or to complete it, or they will only provide you the ray diagram. Based on that one, you should identify it. This is one example that I am going to explain. The rest you can follow with the same method. See here, the prism what you are going to observe here is 90, 45 and 45 degree prism. So one right, we used to call it as right angled prism, where the angle B is 90 degree and A is 45 and the C is 45. Now how the total internal reflection is going to occur, that I am going to explain. See here, let me take the ray of light incidenting here. Okay, so if I name here as P and Q, PQ is the line which is incidenting normally on the surface AB. Then the question arises, what do you mean by a normal incidence? Normal incidence means the ray of light incidenting on a normal line. On the normal line ಮೇಲೆ ray of light incident ಆದರೆ ಅದನ್ನ ನಾವು ಏನಂತ ಕರಿತೀವಿ? Normal incidence. Now see here, if I draw a normal at the surface AC, see here, this is the normal at the surface AC. Now see here, at AB it passes without deviation. As you know very clearly, at the normal incidence, I will be equal to 0 and all will be equal to 0. The ray of light passes straight without deviation. Howdala? But now see here, at this angle, at this particular angle, it forms 45 degree. Okay, now the question arises, what happens? Will the ray of light will passes out, or it becomes total internal reflection? Then I will give you the clear explanation. For air to glass interference, the critical angle is 42 degree. Make a note. The most important statement, what I am telling is very important statement. For air to glass, or air and glass and air, the interference, the critical angle is 42 degree. Critical angle is 42 degree. Now observe, this is the denser medium, glass. This is the denser medium. Outside it is the rarer medium. The ray of light is moving from now denser to rarer. Inside the prism, denser to rarer. How the? Now, the angle of incidence. This is the angle of incidence in the denser medium greater than critical angle. Critical angle is 42 degree. Now it is 45 degree. It is greater than critical angle. What happens? This ray of light occurs with the total internal reflection. It will not move out. The ray of light will not move out. Now see here, this point, you can expect the ray of light changing its direction like this. From here, 45 degree. Are you getting what I am explaining here? ಗೊತ್ತಾಗ್ತಿದೆಯಲ್ಲ? It's very simple. ನೋಡಿ, air glass interference critical angle is 42 degree. Here it is greater than 42 degree. Howdala? I said two conditions for the occurrence of total internal reflection. The ray of light must travel from denser to rarer. Agide nodi, the ray of light is moving from denser to rarer. The angle of incidence must be greater than critical angle. This is also satisfied. See, our critical angle is 42 degree. Howdala? ಇಲ್ಲಿ 45 degree ಇದೆ, more than a critical angle. So at this point, if I mark here PQ or yes, at the point R, it is occurring total internal reflection. At our point ಅಲ್ಲಿ ಏನಾಗ್ತಾ ಇದೆ, total internal reflection ಆಗ್ತಾ ಇದೆ. So it changes its direction through 90 degree and it emerges out. Like this. Sure. This diagram is satisfied. Pakka. Now I will draw with one more ray diagram. See, same thing appears here. Then at this point, it will change its direction and it will be emerges out as here. This is the normal, and once again 45, and here 45. I think you people are clear with the content. How we are going to use a prism to change the direction of light through 90 degree. Through 90 degree, how we can able to change the direction of light with the help of total internal reflection. Sure? Clear? See here, this type of action we are going to see in periscope. ಈ ಆಕ್ಷನ್ ನಮಗೆ ಎಲ್ಲಿ ಕಾಣಲಿಕ್ಕೆ ಬರುತ್ತೆ, ಎಲ್ಲಿ ನೋಡ್ಲಿಕ್ಕೆ ಸಾಧ್ಯ, that is in periscope. Sure? This content is clear? Sure? Then the same thing applicable in a binocular when we are gonna attach one more prism to the left. See here? So let me draw here like this. Okay. Now see here, this is 45. This is 45 and this becomes 90. Right? This action we are gonna experience in binocular. How? The ray of light here at this point, total internal reflection, it changes 90 degree and comes out. Once again, ray of light comes out here, here, here and here. Okay, so let me show with an arrow mark. 1, 2, 3, 4, 5, 6, 7, 8. Then here every time you can check here. This is how we are going to use. This section is used in binoculars. Okay, so like this there are plenty of things that you should know. Here few things that you should concentrate more. What are the things? First thing is the ray of light must travel from denser to rarer and angle of incidence must be greater than critical angle. Here when you are dealing with optical instrument, that is glass, make sure this is more than 42 degree. Whenever you are going to see the angle of incidence in a denser medium more than 42 degree, then at that position total internal reflection will gonna occur. Clear? Okay, then the question arises, sir, for example, in a periscope you can use mirrors instead of prism, right? The question you may ask like this, ಸರ್ ಎರಡು ಮಿರರ್ನ 45 ಡಿಗ್ರಿನಲ್ಲಿ ಇಟ್ಬಿಟ್ರೆ ಆರಾಮ್ಸೆ 90 ಡಿಗ್ರಿನಲ್ಲಿ ಬರ್ತಾ ಇತ್ತಲ್ಲ ಚೇಂಜ್, ವೈ ವಿ ಶುಡ್ ಡಿಪೆಂಡ್ ಹ್ಯೂರ್ ವಿತ್ ದ ಪ್ರಿಸಮ್, ಕಾಸ್ಟ್ ಜಾಸ್ತಿ, ಮಿರರ್ ಆಗಿದ್ದರೆ ವೆರಿ ಸಿಂಪಲ್ ಆಗಿ ಆಗ್ತಾಯಿತ್ತು, ಕಮ್ಮಿ ದುಡ್ಡಲ್ಲಿ ಆಗ್ತಾ ಇತ್ತಲ್ಲ ಅಂತ ನೀವು ಕೇಳ್ಬೋದು. ಆದರೆ ದೇರ್ ಆರ್ ಮೆನಿ ಡ್ರಾಬ್ಯಾಕ್ಸ್ ವಿತ್ ದ ಪ್ರಿಸಮ್. See, when you are going to compare the reflection in a mirror as well as the total internal reflection, here in a prism, the intensity of light will be 100%. Is it clear what I am telling? Here the intensity of the light will be 100%. There is no loss of energy and the image quality will be crystal clear here rather than a mirror. In a mirror, few intensity of the light will be absorbed by the surface of the mirror, but here there is no chance of observation. Whatever the input, output will be done. Okay, so this is the main reason we depend on a prism instead of mirror for the reflection. Clear? So this is the basic concept about your critical angle and total internal reflection. I hope you people are very clear with the content in that. So then we are gonna meet once again with a different content. Till now, take care, but don't forget to like, subscribe my channel. That's it. Till now, take care. Bye bye.